claim that it takes 8 minutes for light to travel to the Earth, right? And but if you're the actual photon, it actually takes no time at all, and you actually leave the sun and hit the Earth at the exact same time. Okay, that's because of time dilation. Yeah, and for me to like show you the math to understand that, I need to take a step back and show you what time dilation is and kind of like why it works, right? And like why it's a thing. Okay, so the idea of time dilation is Einstein, right? Albert Einstein was like, oh, speed of light, my good friend, you can't travel faster than 3 times 10 to the 8 meters per second, right? He was like, you can't do it, not allowed, right? And he was right, you can't do it. But then, what a lot of people's questions to that is, well, okay, what if I had a torch and I was just started running with the torch? Would I then not have travelled? Would I then not have increased the speed of light? You know what I mean? Like compound. Would it not have like added the speed of light and whatever I'm moving? No, because of time dilation. Let's say you're on a truck, okay? We've got this truck, and the truck is travelling at some speed, okay? Obviously, speed is meters per second. You got V, which is speed, and then you got distance, which is weirdly is S and isn't D, which it is, right? And then you got T. So speed is meters per second, time is meters divided by meters per second, etc. Yeah, okay. Right, this truck is travelling at, it travels a distance of VT. Yeah, so S. I'm just going to write it as VT, you'll understand why in a second. You're stood on this truck, okay? Right here, with your muscles. And you have a torch. I'm just going to place the torch on the ground just because it will make it easier to explain. Yeah. Right, so that's your torch and it's on. And so what the light does for you on the truck, you'll just look at this torch, you turn it on, light goes up, okay? So what you just see, the light do that, is all you see, right? And this will travel a distance of CT, right? Just like this is VT, where you got the distance, this is CT, C being the speed of light. C equals 3 times 10 to the 8 meters per second. Okay, C is just the speed of light, right? You see it travel a distance of CT. That's a really bad thing. CT. Sorry, let me redo all that. You see it travel a distance of CT, okay? And because I'm making the claim that there is time dilation and that this is constant, I'm just gonna, I'll explain this in a second, but I'm just gonna make the difference, make it obvious that this is CT1, okay? Just that it's your observation. It could be CTJ, as this is time, this is Joe's time, okay? Right, so I'll just say, well, you're T1. Okay, if we say this lorry has a glass side, right, and so I'm actually stood right here watching this all happen, you posing on this truck, shining a torch for some reason, I don't know why you're doing it, but I'm watching it, right, and I'm watching this, And because this truck is moving, I'm not just seeing it go up and down, am I? This could be the light and the truck. It's, do you know what I mean? Do you know what I mean? Right? It's going up, right? It's going diagonal. So, what I see, I'm just gonna draw this with a blue pen just to show you. Right? What I see is I see it do that. Obviously, you remember from like with the triangles, right angle triangles, right? This is just an upside down right angle triangle. So therefore my blue line cannot be the same distance as your green line. But I'm claiming that C is constant, right? So C has to be the same, which means that my time must be different, because it's the only two things that would affect the distance is the speed and the time, okay? And yeah, so I'm gonna say, well, this is CT. I'm just gonna say it's CT, right? I don't need. I could say it's CT2 or CT Michael, like the T is M, whatever. I could say it. I'm not gonna, but I could. I'm just gonna say it's T, right? I know I've written it there, but I'll write it on here as well, just to show you. This distance is VT, right? And you might question, oh, is that T1 or my T? It's my T because you're not seeing the truck move. I'm watching the truck move, so it's my T, right? Well, you've got your triangle right there, right? Remember, like year 9 maths? Okay, so if I redraw out that triangle just here. Oh, I'll do it in the colours actually. You can see I have flipped the orientation, I have just gone, but it's still the same triangle. Okay, well if you remember from Pythagoras, he said, I use red for this, he said, well, if this side is A, and this side is B, and this side is C, A squared plus B squared equals C squared, right? Well, we have the values for A, B, and C. So we can use them values, right, and we can sub them in, and we will. I'm just going to use black because now I can match on with the colours, but yeah. So A is CT1, right? And that's all squared. Plus B, which is the black one, VT squared, equals C, which is CT squared, right? And now we can expand all that and move it all about. Right, so let's do that. It will be C squared T1 squared plus V squared T squared equals C squared T squared. Okay? Let me think about what the best thing is to do next. Let's move VT over to this side. So it's going to be C squared T1 squared equals C squared T squared plus minus V squared T squared. Okay? And now we can take a factor of T squared out. T squared C squared minus V squared. Okay, and now if we wanted to make T squared the subject, because again we're trying to show that there's some form of time dilation, so there's some difference in time between your time T1 and my time T, so you have to make one of them the subject, so we're just going to make T the subject. Okay, to show that there's some like difference between them. So T squared thus equals, I have just flipped it to the other side, yeah, hopefully you can just see that, equals C squared T1 squared over c squared minus v squared. Right, we're going to take out a factor of c squared, of t1 squared, right? So t1 squared times c squared over c squared minus v squared, right? And we can actually take out, from this, we can actually take out the c squared. We can take out a factor of c, not take out a factor, but make it so that the numerator is 1. You know what I mean? We can divide it by c squared, right? And so obviously this c squared, great, c squared divided by c squared, it's just 1, right? Minus v squared, well, v squared isn't c squared, so it is literally v squared over c squared, right? And this can all be then written as t squared equals t1 squared over 1 minus v squared over c squared. Yeah. You can make that look a bit nicer by actually taking out a root. So we can get rid of these squares. It is literally then just t equals t1 over the root of 1 minus v squared over c squared. Okay. Yeah. So it's a different time, right? To make it. Yeah. Okay. Right. I'll just